Hello, everyone, and I'm really grateful to be here, right, and sharing all this kind of knowledge. And as I talked about YEESI Lab last time, what were we focusing? I thought it would be good for me to explain a little bit on the curriculum. Make sure we have everything in our website. When you visit our website, yes.org, you find everything. And this is Kadege for the Lab PI. So I'll talk a little bit on problem-based learning curriculum that we have developed, and realize all the subjects that we think they are the most important for now for our youth and for our enthusiasts and students to learn and get all this knowledge. Remember, YEESI Lab is funded by National Academy of Sciences, and they got funding from the USDA and the USAID. So let me go a little bit explain on so a curriculum design that also uses a student. This is a problem-based problem-centered curriculum or problem-based curriculum. A curriculum design that also uses a student approach, but that instructs students to look at a problem or a situation and figure out a way to solve it. So teachers expect students to use their real life experiences to determine an answer. So problem-based learning is a teaching method in which complex real-world problems. So we are looking on these complex real-world problems, and here we are focusing especially for those problems that needs machine intelligence, or they need machine vision solutions, and real-world problems, and used as the vehicle to promote student learning of concepts and principles instead of just directly presentation like how I do it, a presentation of just facts and concepts. And instead, you expect somebody to go through and show you how to do it in real, like how do you do analysis of data? How do you get the images, for example? How do you get the data? How are you sure the data is clean? How are you going to clean it if there is a lot of stuff that that are not conducive for a machine learning model to learn? So all this kind of information is quite important. So what are the 4 skills of problem-based learning? So what we are looking for first, not only 4, but we'll talk about the 5th one, which is recurrent. So construct an extensive and flexible knowledge base. That's very important. Like we're trying to build that knowledge base and then develop effective problem-solving skills. Like how are you looking to a problem and how you go with it to solve it, and that's critical on problem-solving techniques. And then 3rd one is to develop self-directed, lifelong learning skills. How do you learn, for example, from different learning materials? Learning materials can be textbook, can be presentations, it can be notebooks, or it can be videos. All these are learning materials. So how do you do this and you follow up all these all these materials and actually get a lifelong learning skills and become effective collaborator? It means how do you communicate with your colleagues, and you have a problem, how do you approach them, how do you talk to them, how do you organize a group to accomplish a complex task? And that's what we're looking for to develop as in YEESI Lab, and make sure like all our youth or students, they gain those skills that are keen to make them experts on the field, make them leaders in the field, and make sure like they can do best and direct Tanzania to a direction that we think is the best. And then intrinsically, you need a motivation inside in you that tells you like you need to learn. You need to learn. For example, there are some kids, a lot of them, who are studying, for example, mathematics in Tanzania, and most of them, they don't know, for example, in A levels, they go there, they don't know what calculus is. They start to learn by themselves. They just collect books. So, but you need to be self-motivated, and then as you learn, you get a lot of these skills, and you gain skills, you move forward and getting all this information, which I think is quite important. Now, so this curriculum actually for machine vision in agriculture has, we're looking on training our youth on machine vision using problem-centered learning, like what I've explained, through common methods like problem-based learning, experimental-based learning, and then research-based learning and project-based learning for solving real-world and cultural problems using machine vision systems. And then this is quite vital because we're looking on techniques actually to develop and make sure like you use machine learning techniques and computer vision techniques, what is called machine vision, to make sure like you solve all these kind of problems in agriculture. And this is quite vital. Now, on doing this, we realized at least 6 courses. We think these are basic and quite important. They are not all. Like machine visions now, there are some universities actually offering BSc programs. Some universities are offering it at master's level and some in PhD. So we have a lot to learn from machine vision. But for youth who have entrepreneurial the heart and they want to develop that skills, actually to develop products that they think they can sell or they can go to market and show and get, for example, seed funding to raise for their companies and make sure they go public and sell all the products. They need these basic skills, and we think we can do this and realize the big picture that we want to achieve. So problems, we'll study actual problem solving and program design using Python, which is basically used by most of machine learning and machine vision scientists. And then we have introduction to digital culture. We will be looking on what is agriculture and what is digital culture and what digital systems can bring to agriculture, and that's vital. For example, how do you realize sensors? How do you do controls? How do you get the images from agriculture? And how do you interpret the images from agriculture? How do you understand the plants, how the plants are, and how they grow, for example? And if we have any from before planting up to while we're selling in e-commerce. Now, before planting, what you can do to investigate, on your field when you're planting, how do you do stand count, for example? How do you count the seeds that have been planted? And you go on like that. Mobile application development, which is quite vital now because most of the applications, if you want users to adopt your applications, you really need to make a mobile application that can be used by users. And machine learning in agriculture, this is vital and this is fundamental because you get all the techniques, all the skills that you need to do for machine learning in agriculture. And machine vision in agriculture, we're talking on using cameras now to realize the information that you get from the plants and animals. And entrepreneurship for artificial intelligence. And here we're looking on starting artificial intelligence startups. How are you going to go about and how do you realize the spin-off in startups and how do you manage them and how do you, for example, fund? And we are looking on this, make it big subject because we expect to have invite people from industry who give lectures to and make sure like they give all this information that we think is quite important and can be realized with our youth and can be important for them to build up those big companies. So on problem solving and program design will be the course actually is about fundamental concept of problem solving concept and designing a program using Python. So after realizing this subject, actually we expect the candidates to have to familiarize with approaches to problem solving and to applying software engineering method to design programs and software systems, and then implement a program using high-level program. And here we are talking about a high-level programming language, which is Python, and then develop an understanding of procedural programming and object-oriented programming. Object-oriented programming is central now in the development of most of the softwares. And we have other programming techniques like event-oriented and the other, but object is quite important because most of these programs actually now you can organize all these in object-oriented programming. So when you realize this subject, it will be possible for you to develop any kind of software, from normal software to like web-based system and from realizing models that you can use, and also use Python as a statistical tool to analyze your data and draw. I really like Python. You can do a lot with Python. And then in digital agriculture, so this actually is about fundamental concept of basics in digital agriculture farming, which is the use of digital technologies in agriculture value chain. So digital technology, including internet, mobile technology and devices, data analytics, artificial intelligence, digital delivery services and apps, which are changing the agriculture and the food systems now. And we expect the candidates actually to gain concept on digital farming and precision agriculture and its concepts and how the approaches, for example, what is site-specific farming and how do you do it? And what are the advantages and what are the disadvantages of this technology? Develop and differentiate precision agriculture from other agricultural engineering fields. Develop an understanding of an importance of precision agriculture and how the use of input is reduced through basic techniques. And this is quite important. And develop an understanding of data management and precision farming. So precision farming actually is looking on reducing inputs while maintaining yields or increasing yield. That's important because if you reduce input, still you make profit, even if you get the same yield. And but reducing inputs has other impacts, for example, with environment issues, like because these are chemicals and there are some of chemicals, they stay there for many years. So if we really reduce them not to use, and there are some of these fertilizers, they've been changing to the soils, and they are not like be recommended to be used most of the time. So by reducing this one, actually we preserve land, and all some of these actual chemicals can be done by floods and be taken to rivers, and they can have a adverse effect to our world, to our earth, to our mother earth. And this is quite important because we need to realize all these techniques in agriculture and make sure like we save inputs. For example, if we save water, we are servicing UN sustainable goals because we're looking at reducing water and making sure like life on land is safe. And this is what we're looking about. And now, so with this section, we'll develop an understanding of remote sensing precision farming, demonstrate an appreciation and understanding of economics of precision farming and the use of electronics to enhance site-specific application of inputs, and then demonstrate an appreciation of digital system for post-harvest activities, develop an understanding of digital technologies in agriculture before planting, and this is quite important, and then demonstrate an understanding of digital extension services for rural settings, and making sure like these technologies are available, and this technology actually help a farmer actually realize the importance of using digital agriculture and using precision agriculture, make sure like they get the maximum yield as they wish to get. And another one which is quite interesting, and I really like this subject, and is mobile application development. And this subject will be practical knowledge of mobile development. You finish here, you go develop your app. So build a complete real world app. So that's what we're looking for. Write iOS and Android apps. We're using Androids in Tanzania most of the time. We have very few people who are using iOS iPhones, but we really need to develop codes that using a single code base, we can get what we want to do it. And then fast track using Flutter learning with practical tips and proven techniques. We can use, with this subject, actually, it's not necessary to use Flutter. We can use any, we have, for example, React Native, right? So we can realize all those kind of, we can have Angular that can be used also to develop these mobile apps, and write production ready code from best practices and become a competent mobile app developer. So we can be Flutter and be anything, but all we need is to develop a code that is running. And this code is not only machine vision, it can be any field. So by gaining these skills, actually, you can go on developing this mobile application to realize the other problems that exist in our nations. Yeah. So machine learning in agriculture, so is about diving deep in machine learning concepts and applications. So with this subject, I really like also this subject because you develop an understanding of basic machine learning, including classical algorithms like linear regression. These are simple ones, or logistic regression. And then you go on learning more polynomial regression, multivariate regression, and then you know how to build a advanced one like random forest, support vector machine, adder boost, gradient boosting. All these are kind of machine learning algorithms that are quite important to learn. And then build artificial neural network using TensorFlow and Keras. Not only TensorFlow and Keras, depends on the instructor, but the instructor also can use PyTorch if they really want to use, because you can use any framework actually to develop these machine learning models. And build a movie recommender system using item-based or user-based collaborative filtering. And this is just for learning. And then design and evaluate A/B test using t-test and p-values, test the results, and also understanding how rainforest learning is. So with this subject, actually, you will learn on models that we are training, that we need to train, like we call supervised learning. And then you can learn from unsupervised, like K-means and the other, K-enable and everything. And then you can have reinforcement learning and how to build robots and bots. And then apply machine learning in real world problems. And here we're looking at real world problems, which is in agriculture domain. Machine vision is what we expect you to gain this knowledge after learning all those kind of stuff. And it's really enjoyable, like understanding how the robots see and the computer sense and recognize the surrounding of agricultural environment. So with this, we expect you to demonstrate arithmetical, logical, and other operation in images, and then understand basic image matrix formats and filters, develop an understanding of the fundamental image filtering and tracking, and how to apply those principles to face detection, for example, cycling and stabilization, can be animal face detection or anything, and perform basic image processing with libraries such as NumPy, Matplotlib, and OpenCV. And then also develop an understanding of using geometric transformations to determine 3D poses from 2D images for augmented reality task and visual odometry for robot organization. And then develop systems that can recognize objects and demonstrate an understanding of basics of visual learning and neural networks for the purpose of classification. This is quite important. Perform computer vision tasks such as image processing and manipulation using OpenCV, a Raspberry Pi. And you can use Raspberry Pi, or you can use any other Linux system-based computer, like you can use Ubuntu. All these you can use actually to realize how powerful these algorithms machine vision are. And then create machine vision GUI apps with Python 3 and OpenCV. This is quite interesting, and see how these images can be analyzed by using machine learning methods, and understand basic image matrix formats and filters. And this is quite important. The last one, which is very rare and is not known for most, is how do you build the fundamental concept of entrepreneurship to commercialize digital innovation ideas in agriculture, because this is quite important and very vital, and not digital innovation in agriculture alone, but in artificial intelligence as startups. So understand the formation and growth of high impact startups in the areas of AI and agriculture, and possess skills important for 21st century technology leaders to foster continuous learning and perform reflection about entrepreneurship. Acquire challenging, interactive, and team-based and hands-on learning experience in entrepreneurship and technology in AI for agriculture. So we expect our students actually to realize their groups and make groups and understand and realize what they want to do next. And if you are going to start a startup or a spin-off from the university, how are you going to go about? And then transform artificial intelligence or machine learning ideas into full entrepreneurship application and innovations. And this is what we are looking for Tanzania. We need to, so this is what we want you to achieve. Not only the subjects, because we don't have exams in these subjects, we just learn and go on doing this. So, but this is the end output that we are looking for. Are we going to really have people who have the capacity to build up artificial intelligence startup with a certain idea and make sure they go forward with it, show people what they can solve, and people get interested and be engaged on their startup. So I really wish you all the best. And if you have any question or anything, you can reach me, kadefue@sua.ac.tz, or you can check my website, kadefue.com, and you get all those information. But make sure you visit our lab, yes.org. Thank you. Bye-bye.